out. What I told you on Friday was that on 6.2, I go ahead and start talking about matrices on 6.2 because I'm not going to show you how to solve a 3x4 by hand. So on Friday, all we had was 3x4s, and I just went ahead and started showing you matrices because we're eventually going to do matrices anyway, and I'm not going to ask you on a test or a quiz to solve a 3x4 by hand. I just don't feel like there's a whole lot of benefit for you to ever need to be able to do that. So because we can do it in our calculator, anytime you have to solve a 3x4 anyway, then you can always use matrices. A couple of things today that we're going to talk about. We're going to kind of get into matrices a little bit. We'll talk some more about matrices later in the chapter. One of the things that we didn't really talk a whole lot about on Friday was the order of matrices. So if I have a matrix that looks like this, all that we talk about when we talk about the order of a matrix is we're always going to do rows times columns. Okay, and in this one, there's two rows. Rows go across, and columns go up and down. So this is a 2x3 matrix. And so that's one of the things that we'll use to name it is its size, or how many rows and columns it has. And it's you'll find out as we get into the chapter later on that the size does matter, the difference, the way that it's aligned is going to matter for doing different operations to it. Because if I give you a matrix like this, this is a 3x2 matrix, and those are completely different. And then when we get into doing like, not until Thursday, but when we get into section 6.4, we'll start talking about doing like addition and subtraction and multiplication and doing different things with matrices, and the dimensions of that matrices are going to make a huge difference on what we can and cannot do when we do those operations. Okay, so order of matrices is going to be a big thing. Another thing today, and we talked about this a little bit on Friday, but we didn't really use this term, is augmented matrices. We wrote our equation that we had into an augmented matrix, but I didn't really use that term on Friday. If I were to give you 2x plus 3z equals negative 8, 4x minus y plus 6z equals 7, and then 9y plus 4z equals 1. If I ask you to put that into an augmented matrix, is basically what we did on Friday. When it's 3 variables and 3 equations, we're going to make it a 3x4 matrix. So we have to write a 3x4 matrix that would represent this. Okay, and for this one, we're not necessarily going to solve it. We're just writing the augmented matrix for it. Okay, and you'll have a couple of problems like this on your quiz on Wednesday where you're not really solving it. You're just writing the augmented matrix that represents that equation. So the things that you got to be careful of here. First of all, your variables have to be in the same order all the way across. And most of the time it's going to be x, y, z. So in this case here, there is no y. So when I write out my matrix, this would be 2, 0, 3, negative 8. And I kind of told you on Friday, I always like to put that imaginary dashed line. Your calculator won't have this dashed line in there, but that's where the equal sign goes, just to kind of separate everything. And then we have a 4. And then here's the ones you really got to watch out for. The zeros when it's missing 1, and then if there is no coefficient, it's a negative 1. And then a 6, and then a 7. And then down here, there's no x's, 9y, 4z, and 1. Okay, and that is an augmented matrix. If it's 3 variables and 3 equations, and I know on Friday we took it one step further and we put this into our calculator and we solved it, but on ones like that, you probably don't want to solve it because it's not meant to be solved, and so your answer's probably going to be kind of funky anyway. So just put it in the augmented matrix, and that's all you got to do. We also will go the other direction as well. If I gave you the augmented matrix, and this is the one thing that we did not see on Friday, was we only had 3 by 4s. We only had the 3 variables and 3 equations. Now today, they're going to add in the 2 variables and 2 equations. Kind of like what we did on the very first lesson where we had x and y and we solved by substitution, elimination, graphing, and all of those. But now we can also solve these by matrices. If this is a 2 by 3 matrix, then we're going to write it as a system of 2 variables and 2 equations. So this one does not have the third variable in it. It doesn't have the z. It just has x and y. So when I write my equation here, it would be 2x minus 3y equals 6, 4x plus 1y equals 7. So we just have to be able to go back and forth. If I gave you the matrix, you should be able to write the equation. If I give you the equation, you should be able to write the matrix, okay, for either one of those. And like I said, you'll have a couple of problems on your quiz like that on Wednesday, and it should be pretty easy points because you don't have to solve it, you don't have to do anything else to it. You're just rewriting it in a different form. Okay. All right, if you would get out your calculators, and if you have your book, you can get your book out. We're going to do a few problems out of your book together. We are on page 435. And if you don't have your book out, I'll put the problems up here. Let's do a 2 by 3 that we did not do. So if I write out x minus 4y equals 9, and this is number 22 if you want to follow along in your book, 2x plus 5y equals 5. Okay, the directions in your book say solve the system of equations using Gaussian elimination, or use a graphing calculator to check your answer. So I'm not going to ask you to do, basically Gaussian elimination is just using elimination to solve this, and I'm not going to ask you to do that, okay? So we're just solving this by our calculator today. And so the first thing that we're going to do is we're going to put in whatever the matrix is. So in this case, it's 1, -4, 9, 2, 5, and 5. This is a 2 by 3 matrix. Okay, so especially if you did not watch Friday's lesson or do these problems yet on your calculator, then we're putting this into our matrix. But on Friday, we only did 3 by 4s, so this one's a 2 by 3. So you're going to put it into the matrix, whatever matrix you want to put it into. So you go to matrix, you go to edit, you put it in as a 2 by 3. Okay, and then once you have it typed in, you're going to go back to matrix. You're going to go to math. And you're you're going to do R, R, E, F. And what that stands for is reduced row echelon form. You don't necessarily need to know what that stands for. I'm never going to ask you that, but it's putting it in a certain format, and then you're going to do it of matrix A, RREF of matrix A, or whatever matrix you put it into.
Where is that at?
You got to go to matrix, you got to go to math, and then scroll all the way down to RREF. And make sure you get the one that has two R's in it, because there's one that just says REF. Okay. Or Casios are a little bit different. Everybody that has a Casio know how to do it on their calculator? Does anybody have a Casio that not know how to do it? The punching it in is a little bit different. So we get something that looks like this. Okay, when you're, and on Friday it looked a little bit different. On Friday we had a 3x4, so over here it looked like this. There's just more variables. But what we have is we have a diagonal of ones, and then we have zeros in every other slot. Well, we have basically the same thing here. This is what we call reduced row echelon form, okay? And then you have two numbers over here on the right for this problem. And I have 5, -1, okay? That is the answer to that system of equations. Last week we talked about doing that by graphing, substitution, elimination. Obviously this is a lot quicker, okay? I will tell you again that on the quiz on Wednesday, there are some that you will have to graph, you will have to do substitution, you'll have to do elimination, okay? So you'll have to do those three methods that we did last week. But if it just says solve and I don't tell you what method you can use, then you can always do this. Or if you want to check your answer, you could always use your matrix to check your answer as well. But you will have each one of those methods that you'll have to show the work for to get the full credit on each one. Okay, anybody have questions on their calculator as far as that goes? Okay, let's look at this one's number 35 in your book. I'm just going to go ahead and write down the matrix. I'm not going to write the equations out. First, and they're using different variables here. So that's one thing I wanted to talk about here. It's not always going to be X, Y, and Z. This one happens to be P, Q, and R. So this one says P plus Q plus R equals 1. And then 1P plus 2Q plus 3R equals 4. And then 4, 5, 6 equals 7. Okay. And I'm totally okay with you just going right into your matrix since that's what we're doing today. You don't have to rewrite the equations on your homework. Okay, we're going to put this in as a 3x4. So let's practice putting this one in. Let's see what happens. And then the same thing, we're going to do RREF, and this time, whatever matrix you put it into, this time I put mine into B. Okay, but here is the problem that you're going to have to watch out for. When we do this, this is the matrix I get back when I do RREF, okay? What you have to have is you have to have that diagonal of 1. So that's the first indicator that something is not right, okay? And all of these should be zeros. Well, I got zeros down here, but these are not all zeros right here, okay? So this is one of those that are a different solution. So then I have to decide which type of solution do we have. If I see a whole row of zeros, basically what you got to remember here is this is X, Y, and Z, or in this case it's P, Q, and R. So it's 0P plus 0Q plus 0R equals 0. So if I said 0 equals 0, remember that imaginary dotted line right here, then what would I say if I have 0 equals 0? Infinitely many solutions, okay? And here's what I will tell you is the book writes it a little bit differently. Like here, they write it as r minus 2 because this is r minus 2. I don't expect you to write it like that. If you just write IMS, then I'm okay with that. And so I don't think I put it on my key like that, but in the textbook, that's what you'll see sometimes. So don't worry about writing it like that. Just write infinitely many solutions, and I'm good with that. Okay, try number 36. This one uses m, n, and t. So you're going to see different variables being used, but don't let that throw you off. We just got to make sure they're all in the same order. M, n, and t are all in the same order. There's no way to really look at this equation right from the beginning and say, oh yeah, this is a no solution, infinitely many, or it's going to have X, Y, and Z, or it's going to have solutions. So we have to put this into our calculator. So once again, we're going to put this in as a 3 by 4. Same process, RREF. Okay, this time, my matrix does look a little bit different again. Okay, and really it's this right here. This diagonal right here all has to be ones. If they are not all ones, and I don't have zeros in all the other spots, that's the indicator that something's not right, okay? That's how we know if it's infinitely or many solutions or no solution. Okay, so if that's the case, then I look at this bottom row typically, and I say 0, 0, 0 equals 1. So does 0 equal 1? And it doesn't matter what number's here. This could be 7 or anything else. But if I see a whole row of zeros equals 1, we know that that is not true. 0 does not equal 1. So this is a no solution. Okay, so I just wanted to kind of review again. And the same thing would be true for a 2 by 3. If we had a no solution or infinitely many solution on a 2 by 3, then it would just be 1, 0, 0, 1. So then I would have to have 2 ones right here with zeros in those 2 spots. And if it's not like that, then we know it's no solution or infinitely many solutions. So those would look very, very similar as well. Okay, I told you that you're going to have some story problems on your quiz on Wednesday. One of the story problems is going to kind of look like this problem here. This one is number 41. Okay, and this one's by far and away the hardest of the group because they give me a situation, a story problem with a bunch of numbers in it, and there's no equations given to us. There's just a bunch of information. So what I have to do is I have to rewrite all of the equations, not rewrite, but write them all out. And then obviously I can use my calculator to solve. But if I don't write the equations out correctly, then it doesn't really matter what I do from there because my equations are wrong, okay? So you've got to make sure you read the problem carefully and know exactly what's going on. So I'm going to do one here with you. We'll have some on the review tomorrow as well, just to kind of get some practice. This one is talking about a manufacturing company for some equipment. They're borrowing money from 3 different places at different percentages. Some is borrowed at 8%, 10%, and 12%. So this is a money question. We're borrowing some money. The annual interest earned is $3,040, and the total amount borrowed gives me a couple of different things. So the first thing we're going to do here, you can use whatever letters you want to. Typically, I just go with X, Y, and Z. It says to figure out how much money is borrowed at each rate. So for X, I'm going to say X is the amount of money that I'm going to borrow at 8%. Y is the amount of money borrowed at 10%. And then Z is the amount of money borrowed at 12%. Okay. Those are the three amounts that I borrowed money from a bank or a lender of some kind. The total amount of money borrowed was $30,000. Okay, so these three loans or different accounts that I borrowed a total of $30,000. Okay, and a lot of people would think, oh well, it's 10,000 of each, but it's not. It's going to be different combinations, but that's the right idea. Those three amounts are going to add up to be 30,000. Okay, but they're not all going to be the same. So that's the first thing, is don't think that they're all going to be the same amounts. That would be the easy way to go, right? Okay, now, if I get charged interest, if you ever have a loan at a bank, car loan or a home loan or whatever, okay, they're going to charge you interest based on your interest rate. 8%, 10%, 12%, whatever it is, okay? How does that get charged? If I have an 8% loan at the bank, then how do they charge me interest on that loan? What would be the math that gets done there? If I borrowed, let's say, $1,000 at 8%, how much is the bank going to charge me that year? What would I have to do? Okay, how'd you get that? Yeah, just multiply, right? We're going to take whatever this is times 8%. So we're going to take 0.08 times X plus 0.10 times Y plus 0.12 times Z. And they said the total interest the banks or the three accounts are going to charge me was $3,040. So I have to pay $3,040 in interest for those three loans. Okay, that one's not too bad because it's just a straight interest equation. So you got your total amount of money, you got your interest equation, and then the third one's kind of tricky. The last sentence, the total amount borrowed at 8% and at 10% is twice the amount borrowed at 12%. So the amount borrowed, okay, and here's where you got to be careful. Is it the amount borrowed or is it the interest paid? Okay, this one's saying the amount borrowed, and that's what X, Y, and Z represent. So I'm going to say X plus Y equals twice the amount borrowed at 12%. So 8% and 10% together is double the amount borrowed at 12%. Okay, those are my three equations. Now, can I put it into the matrix just like that? What are we going to have to do? Yeah, we're going to have to move the Z over, right? We're going to have to get everything lined up. X, Y, and Z all have to be on the left. So what I'm going to do is I'm going to rewrite this one. I'm just going to move it down here. X plus Y minus 2Z equals, and if I move 2Z over here to the left, then there's nothing left on the right. That would be our third equation. Okay, when we put this into our calculator, we're going to do 1, 1, 1, 30,000, 0.08, 0.10, 0.12, 3,040, and then 1, 1, negative 2, 0. Try putting that one in. And I think they come up to be nice whole numbers. And then what I get here is I borrowed $8,000, $10,000, $12,000, and $10,000. Okay. And if you did it right, one thing that you would always want to make sure of here is, does my answer make sense, right? Because if you messed up your equations, then your answer is not going to match up either. But first of all, these three should total up to be $30,000. If those three add up to be $30,000, then we should be good. I mean, you could check these other two, like this one here. X and Y together is double what Z is. So if I add 8 and 12 together, I get 20, and that's double of 10. So it does match up with all of our things. Okay, you could do the interest one as well if you wanted to, but if the three add up to be 30,000, then you should feel pretty good that your answer should work. But you could check all three equations. Okay, so that one definitely is the hardest of the group because you got to be able to set the equations up. It's not going to give you those equations. Okay, questions on that one? You'll have one very similar to that on the review and then on the quiz as well. So that's why I wanted to go through that one with you. Okay, the last thing I'm going to go through with you here. And I think this is off of Friday's assignment. We didn't talk about this on Friday. All right, this is page 428, number 34. It gives me this table. And this is not a matrix problem. That's why I'm going to go through this one with you. This is the year. This is the number of deaths on in thousands from a motor vehicle. Okay, so it gives me 2016, but that's what we call year zero. It kind of goes back to what we did in the last chapter with exponential functions, where year zero is the year we started collecting data. And then 2019, and then 2021 is 5, and then this is 40.3, this is 39.1, and this is 47. Okay, so this, and it's in thousands, so this would represent like 40,300 deaths. All right, so what it's asking for, part A, which is at the top of the next page, it's asking us to write a function in this format. X is the number of years after 2016. Okay, so we want to write a function. Now, you could do this with matrices, but we're not going to do it with matrices because I'm going to show you a quicker and easier way of doing this. We did this way back early in the semester when we did like a linear function, and we did what we called a linear regression model. What kind of function is this right here? Quadratic, right? AX squared. When I see that x squared in there, it's a quadratic equation. So this would be a quadratic regression model. And so we want to write a quadratic equation that represents that data as best as we can, okay? And instead of doing it by hand, which you could do with matrices and that kind of stuff, we're going to let our calculator do the hard work for us, okay? So here's what we're going to do. This is a little bit different place than matrices. This is not a matrix problem. Okay, so what we're going to do here is we're going to go to stat on our calculator. And we're going to go to edit. Okay, and you should have a bunch of lists there, and it has like L1, L2, L3, but under L1, we're gonna put 0, 3, and 5. You're not gonna put the actual year in, you're gonna put how many years since 2016. So if you put the year in, your data is gonna not be correct. So we're gonna put in 0, 3, and 5. Okay, and then under L2, we're gonna put 40.3, 39.1, and 47. Okay, and your table might be, a bunch of different data points, but in this case, we just have 3 data points. So we want to write an equation that represents all 3 of those data points. So now what we're going to do is we're going to go back to stat. We're going to go to calc. And if you have a Casio, I'll help you with this because Casios are going to be a little bit different. And it's asking us to write a quadratic regression model. Well, on your TIs, that's number 5. So we're looking for quad reg. And some of you are going to have to go down to like calculate. And it gives you an A value, a B value, and a C value. Okay, so that's your A value, B value, C value. So my equation then would look like this. 0.87 x squared minus 3.01 x plus 40.3. And that's my equation. Okay. It does have a second part to it where it says, find out how many deaths would occur in 2018 and 2022. I'm not going to ask you to do that on the quiz, but you will have a problem like this on the quiz, and it's strictly just a calculator problem, but it's not a matrix problem, so it's a little bit different. There is a way to do it with matrices, but I'm not going to show you that because this is a much easier way of doing it. Okay. If you need help with that one on your Casios, let me know, and I'll come around and help you with that one. Okay. I'll put the assignment up here, and then if you need help with anything on your calculator, let me know, and I'll come around and help you out. Okay, 1 through 13 is just identifying the size. It's rewriting it. You're not doing any solving on the first 1 through 13. And then when you get 15 to 35, that's where you're doing the solving. You can just put those right into your calculator. Okay, I did not give you any story problems on your homework. I think there was on Friday on that one, but there will be some on the review tomorrow that you'll have to do.